Hello everyone, this is Abhishek Das. I'm a structural engineer at ACOM, and today I'll be discussing about the proof checking of composite steel I-Girder bridge, which is located in the UK. I'll be talking about mainly the analysis and design aspects of the bridge. We've used the software Midas Civil for most of the design. In the next 30 to 45 minutes I'll take you through the basic workflow, what we followed, and how the software helped us in doing that. Okay, so in today's presentation we'll be doing the following contents. I'll be talking about the general description of the bridge, the geometry and all, and then we'll be moving on to the design actions that were considered, analysis and construction aspects, and finally the capacity checks and design. So the site location is basically the M6 to M1 link. This is the present scenario on the left hand side. We have the M6 motorway on the left, and then on the right we have the A14, and from north to south we can see the M1 road, M1 motorway. Now there are some new developments in this particular area. We are going to have a lot of new structures. You can see on the right hand side there are about 10 new structures coming up, which are basically because of the congestion of traffic in the existing network. So our main focus will be bridge number 3, which you can see here. The pier locations are marked. This is a 6-span bridge. You can see the skewed piers near where the 3 is written. This is going to be the span arrangement in more detail. There are total of 6 spans, and then most of the piers are skewedly placed. You have piers 3, 4, 5 in the east abutment, which are having a very high skew of in the range of 60 degrees, so that they can align with the proposed M6 A14 link, which is going under the bridge. And that's the elevation. This is the carriageway information. You have 6 composite steel I-girders with the bracing system in between. Overall width of the deck is 16.6 meters. The carriageway is 7.3 meter wide, which according to Eurocode will be designed with 2 notional lanes. And then you have the reinforced concrete deck slab, which is a 250 millimeter thick. Okay. The overall depth of the girders is 1.7 meters, and you have 2 verges on either side, 2 meters each. Okay. The bearing articulation of the bridge is as shown here. Pot bearings have been used, okay. And all the bearings are having a free type of notation, which is free in translation in the lateral and the longitudinal direction, except for the central bearing for each pier. As you can see here, the central bearing for each pier has been guided with respect to the bearings on central bearing on pier number 2. Pier number 2 has fixed bearings, fixed in X, Y and Z translation. The columns are free to sway such that they can take the temperature movements. Then the abutments and piers are reinforced concrete. Piers are basically circular in shape, which are with a torch shape, tapered. I mean, on the top they have a larger dimension, and then tapered, and then finally having a dimension of 1.4 meter dia. It's supported on a pile cap with piles which are board piles. The board piles have been used here because of the depth, or because of the length. Maximum length of the piles was going around 21 meters, and normally we would use CFA piles up to a depth of 12 meters because construction is very fast with CFA piles. Typical diameter of the piles used is 750 millimeters. Abutments are 1.2 meters thick. Now there was some cost comparison done just to give an idea about what different other bridge alternatives had been selected. In basically two bridge types were being looked upon. One is the ladder beam deck, which has two very deep main girders on the edges, and then in between they're supported by cross girders. So the cost was for a two-span system for either ladder deck or multi-girder deck was too high, so it was rejected. And proposed structure consists of multi-girders, and this was seen to have a much economical cost from the cost point of view, and therefore this particular option was selected. The ladder deck option was rejected also because of the aesthetics point of view. It didn't match with the other set of structures that were coming up in that particular location. This is information about the material grades used. C40 cylindrical strength for the deck piers, and for the abutments and piles 32 MPa strength of concrete was used. Structural steel work is S355 grade steel. Weathering steel was used. The benefit of weathering steel from the environment point of view is very good because it doesn't require any paints, artificial paints, which is good for the sustainability and environment. Also, it can be recycled easily and reused. A permanent formwork was used on the bridge, which is in the form of precast concrete planks. This serves in also providing some additional thickness to the existing reinforced concrete slab, thus increasing the structural strength of the composite steel girders.